To download the dataset for today's project, open your browser and search Customer Churn Prediction Kaggle Dataset. Click on that and you will find the bank customer churn dataset. Click on that Kaggle link. The page has opened. As you can see, the dataset format. We have customer ID, credit score, country, gender. Now click on download and download the zip folder. Once it is downloaded, open it and extract the file. Extract the Excel file and open it. Once the file is opened, you can see customer ID, credit score, gender, age, tenure, balance, products, ID, and churn. Hey everyone, welcome back to the channel. Today we're going to walk through an end-to-end customer churn prediction project using Python. We'll explore data, do some feature engineering, train multiple ML models, and compare their performance. Step 1. Imports. Import pandas as PD, imports numpy as NP, import matplotlib.pyplot as PLT, import cbond as SNS, from collections, import counter. Pandas for handling data frames, reading CSVs, etc. NumPy for numerical operations like arrays, math functions. Matplotlib and cbond for visualization. Counter helps count occurrences in a list of series. From sklearn.model selection, import 10 test plate, stratified k-fold, cross valve score, grid search CV. From sklearn.preprocessing, import standard scaler, min max scaler, one hot encoder, and level encoder. From sklearn.compose, import column transformer. From sklearn.pipeline, import pipeline. From sklearn.impute, import simple imputer. Train test split for splitting data into training and testing. Stratified k-fold for cross validation, keeping class distribution intact. Cross validation score for evaluating models with CV. Grid search CV for hyperparameter tuning, standard scaler and min max scaler for normalizing numerical features, one hot encoder and level encoder to convert categorical data to numbers, column transformer to apply transformers to specific columns, pipeline which helps in chaining the preprocessing plus model in one step, simple imputer to fill the missing values. Models. From sklearn.linear model, import logistic regression. From sklearn.assemble, import random forest classifier, gradient boosting classifier, ADA boost classifier. From sklearn.svm, import SVC. From sklearn.naive bias, import Gaussian NB. This we are importing different ML models to try and see which predicts Churn best. Then, for metrics and utilities, from sklearn.metrics, import accuracy score, precision score, recall score, F1 score, ROC AUC score, confusion matrix, classification report. From import joblib, import warnings, warnings.filter warnings ignore. Metrics helps in checking how good our model is. Joblib saves the trained model for later use, and warnings.filter warnings ignore hides unnecessary warnings. Display setting SNS.set style white grid palette muted font scale 1.05 pd.set option display.max column 200 makes plot prettier and data frames fully visible in Jupyter Notebook. Step 2 is loading the data. df equals to pd.read csv customer data.csv print shape df.shape df.head loads the csv into a data frame print shape rows into columns and head prints the first 5 rows. Step 3 is initial inspection. Display df.info, display df.describe, include all. Info helps in printing the data types and missing values, and describe summarizes the stats, mean, max, print missing values per column. Print df is null sum, checks which columns have missing data. Print df churn dot value counts normalize for equal to false. Print churn proportion. Print df churn dot value counts normalize equal to true. How many customers churned versus stayed. Normalize equal to true gives the proportion instead of counts. Alright guys, now comes one of my favorite parts of any machine learning project, the exploratory data analysis, a simple EDA. This is where we visualize our data to actually understand the patterns hidden inside it. So first I have selected some numeric features like credit card score, age, tenure, balance, number of products, and estimated salary. Then using a loop, I am plotting KDE plots or kernel density estimation plots. These basically show the distribution of a feature for churned and non-churned customers separately. Think of it like this: if the two curves overlap a lot, the feature might not be very useful for prediction, but if they are clearly separated, that's a strong indicator. Next, I have used a pair plot to quickly visualize the relationship between numeric features. This helps us spot any interesting interactions, like whether higher balance customers are less likely to churn or how age relates to churn rates. It is also a great way to visualize, confirm correlation before jumping into modeling. Here's a Violin plot showing how age is distributed across churn and non-churn groups. Unlike a simple box plot, Violin plots show both the distribution and qualities, so you can see how most customers clustered around certain age range. Now let's look at tenure. Basically, how long a customer has been with the bank. This bar plot shows the customer with the shortest tenure might be churning more often. It is useful insight for retention strategies. Next up, gender analysis. I have grouped data by gender and calculated churn proportion. Then, using a donut chart, we can clearly see whether male or female customers churn more frequently. It is a simple yet powerful visualization for demographic insights. Next, I also plotted count plots for categorical features like country, gender, credit card ownership, and active membership status. This helps us see which categories have higher churn counts visually. Now, this is the correlation heat map, one of the most important visualizations in EDA. It shows how strongly each numeric feature is related to other. For example, if balance and product numbers have a higher correlation, this means one can partially explain the other. Finally, here's a scatter plot comparing balance with number of products colored by churn status. Ideally, people with more products should be more loyal and churn less. But if the opposite happens, that's a red flag for the company. So that's wrap up our visual analytics part. EDA gives us the institution about the data, and this intuition is what helps us build smarter and more accurate models later. Next, we'll move into feature engineering, where we will actually create new, meaningful features from what we just explored. Step 5, Feature Engineering. So, feature engineering means creating new features from existing ones, features that can capture hidden relationships in the data and help the model make smarter prediction. First, we create a feature called balance per product. We divide the customer's total balance by the number of products they hold. This helps the model accurately understand how effectively customers are distributing their money across products. Next, we calculate salary to balance ratio. That's simply the estimated salary divided by the balance. Why? Because a person with very high salary but almost zero balance might behave differently. They could be transferring money out quickly, possibly less loyal. Then we categorize customers into age groups like under 25, 25 to 34, 35 to 44, and so on. Grouping age helps capture behavioral patterns like young professionals versus mid career individuals versus retirees. So we can create tenure buckets. For example, new customers with less than a year, those with 3 to 5 years, and long term ones with over 10 years. Churn rate often varies based on how long someone has stayed with the bank. Lastly, we add a simple yet powerful binary feature, high balance, which marks whether a customer's balance is above top 25% of all balances. This helps the model identify premium customers. These extra engineered features give our machine learning algorithm much more context, making prediction far more accurate than using raw data alone. Step 6, Data Preprocessing. Now that our features are ready, we need to preprocess the data. Machine learning models don't understand missing values or text, so we build pipelines to handle them automatically. For numeric columns like age, balance, or credit score, we first fill any missing values using the medium. Why medium? Because it is less sensitive to outliers compared to mean. Then we scale all numeric features using standard scaler. This ensures every feature has equal weight and does not dominate the model just because it has large range. For categorical features like country or gender, we fill missing values with the most frequent category and then apply one hot encoding which converts text labels into binary vectors that ML model can process. Finally, we combine both these transformers, numerical and categorical, into a column transformer. This way, our entire dataset is cleaned, encoded, and scaled all automatically before training. Step 7, Train Test Split. Next, we split our data into training and testing set. We use 80% for training and 20% for testing. But there's one smart trick here. We add stratify equals to y. This ensures that the proportion of churn and non-churn customers remains the same in both sets. So the model does not end up learning from an imbalanced sample. It's a small but important detail that improves performance consistency. Step 8 is training multiple models. Now it's time for fun part. Training multiple machine learning models. We are not relying on a single algorithm. Instead, we will test our multiple ones like logistic regression, random forest, XGBoost, or maybe even SVM or gradient boosting and compare their results. We create a single pipeline that includes one preprocessor and model. Then we use cross validation, which splits the training data into multiple folds, training on some and validation on others to ensure the model performs consistently. We ensure each model's performance using ROC score. That's a metric that balances sensitivity and specificity, perfect for classification problems like churn prediction. At the end, we pick the model with the highest AUC score as our best performer. Step 9 is evaluate the best model. After identifying the best model, say it's random forest or XGBoost, we train it again on the full training data. Then we use it to predict on the unseen test data. And this is where we see how well our model generalizes. We print out key metrics like accuracy, overall correctness, precision, how many predicted churns were actually churns, recall how many real churns were caught, F1 score, a balance between the two. We also look at the ROC AUC curve and confusion matrix to visualize true positives, false positives, and so on. If you notice any imbalance, like too many false negatives, we might need to fine tune the model later with hyperparameter optimization. Step 10 Feature Importance. If our best model is tree based like random forest or XGBoost, we can even extract feature importance. This tells us which factors contribute most to predicting churn, like maybe active members or balance per product are the strongest signals. This is super useful for business teams to know why customers are leaving. Step 11. Saving the model. Once we're happy with our results, we save the entire pipeline using job-lib. This means the next time we don't need to preprocess or retrain from scratch. We can just load the pipeline and start predicting instantly. Step 12 is predicting for a new customer. Finally, let's test our model with a new customer sample. We apply the same feature engineering, feed it into our saved pipeline, and it gives us two things: whether the customer is likely to churn 0 or 1, and second, the probability score, showing how confident the model is. That's how we can use this churn prediction model in real world banking systems to proactively identify customers who might leave and take action before it's happened.